A permutation is a very special type of function in this class. We're going to focus on permutations of a finite set of elements. In this class, we will focus on permutation functions. What is every permutation? Every permutation is a function. It's a special type of function. So we're going to focus on permutation functions on a set of n elements. And so in particular, remember, in function notation, we're going to call permutations pi in general. And permutations, the first thing to recognize about permutations, can someone use the words domain and codomain? Every permutation has a domain of the set of n elements and a codomain of the set of n elements. And another way to write that is every permutation goes from the set 1, 2, 3, 4, all the way to n, and goes into the set what? All the way to n. What is a permutation? It's a set of n elements. Great. Say that again. What's a permutation? I don't think I... It's a function. What's a permutation? Function. Okay. I haven't finished the definition of permutation, by the way. So far, what do we know about the permutations we're going to focus on in this class? What's the set of inputs? What's the set of outputs?
Oh, it's the same.
The set of inputs are the set of numbers 1 to n, and the set of outputs are the set of numbers 1 to n. Every permutation is a bijection. It is both 1 to 1 and onto. In other words, meaning 1, that the range of the permutation pi is equal to the codomain, and if x comma y is an element of the permutation, yeah, I guess I should write it in the way that you're all used to. I'm sorry. If pi of I equals k and pi of j equals k, then what? J. There's no way that the same output could have two different inputs. And my claim is that must be true here. You could actually, one of them implies the other one in this particular case. We will say S sub n is the set of all permutations pi where pi is a permutation on n. What is a permutation? It's a function. What type of function is it? It's 1 to 1 and onto. S sub n, this thing is called the symmetric group on n elements. This comes from abstract algebra.
It's onto the first condition and 1 to 1 the second.
Either one. It doesn't. You could. Either one. Doesn't matter which one you do first, right? This is onto. Oh, I'm sorry. That's what you're asking. You're asking what the word onto correlates to and what the one-to-one correlates to?
Yes.
Yep. So S sub n, what's that called? The symmetric group on n elements. What is it? It's the set of all permutations of the set n.